The year is 1957. The heat of the American summer begins to yield to the crispness of autumn, and in the heart of the nation's political and intellectual centers, a profound and terrifying silence is shattered. On October 4th, a simple, gleaming sphere, roughly the size of a beach ball, arcs silently over the twilight skies, emitting a steady, chilling sound. Beep, dot, 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 beep, dot, dot, beep, dot, dot, beep. This sound, heard across countless shortwave radio, was not the sound of progress, but the sound of absolute vulnerability. It was Sputnik, and it was Soviet. The technological superiority of the United States, a foundational pillar of its global identity and security doctrine, had been obliterated in a single moment. The psychological impact of Sputnik cannot be overstated. It was not just a satellite orbiting Earth. It was weaponized anxiety launched directly into the American psyche. If the Soviets could place a satellite into orbit, they could certainly launch a nuclear warhead capable of traversing oceans and striking the American heartland with impunity. The immediate response was visible and dramatic: the creation of NASA, massive increases in research and development funding, and the panicked push for an American satellite to answer the Soviet challenge. But beneath this overt public response, a shadow program began to coalesce within the labyrinthine structures of Washington's intelligence community. This was a war fought not with rockets and astronauts, but with microchips, faulty blueprints, economic leverage, and the systematic exploitation of human weakness. This was the genesis of America's highly classified program of strategic denial and technological destabilization, aimed squarely at the Soviet Union's burgeoning capacity to challenge the heavens. The secret sabotage program against the Soviet moon mission. The mandate was simple in its horrifying clarity. The Soviet Union must not win the race to the moon. Losing was unacceptable. Losing carried the intolerable risk of granting the USSR unparalleled geopolitical legitimacy and technological leverage that could shatter the fragile balance of the Cold War. The covert response, orchestrated primarily by the Central Intelligence Agency's Directorate of Science and Technology, in partnership with components of the National Security Agency and the newly formed Defense Intelligence Agency, moved beyond simple intelligence gathering. Their goal shifted from passive observation to active surgical intervention, a deep game designed to make Soviet rocketry fail, ideally through internal systemic collapse, leaving no detectable fingerprints of American interference. The prime target was quickly identified: the Soviet Super Heavy launch vehicle, the N-1. This colossal rocket, the brainchild of chief designer Sergei Korolev, was the Soviet answer to America's Saturn V. It was an engineering behemoth designed to carry cosmonauts to the moon and secure global supremacy for the Soviet Union, but it was also, critically, an assembly of immense complexity, built under crushing timelines, constrained by chronic material shortages, and crippled by the brutal internal feuds that characterized Soviet rocketry. Especially devastating was the public rivalry between Korolev and the powerful engine designer Valentin Glushko. This internal friction, this pre-existing structural weakness, was precisely the vulnerability the American intelligence community sought to exploit. The first phase of the operation, which we can call Project Tantalus, was purely observational, establishing the baseline of Soviet capabilities. High-altitude U-2 flights initially provided early imagery, but these were insufficient for the level of detail required. The breakthrough came with the Corona program, the highly secret reconnaissance satellites launched initially in the early 1960s. The imagery, dropped by parachute and captured mid-air by specialized aircraft over the Pacific Ocean, began mapping the physical reality of the Soviet missile and space infrastructure with unprecedented clarity. Baikonur Cosmodrome, the secretive site known internally as Teratum, came into sharp, undeniable focus. Analysts meticulously tracked the construction of the vast assembly building, the unique horizontal integration process for the N-1 stages, and the massive launch pads, Pad 1 and Pad 2, that defined the Soviet lunar ambition. The imagery revealed the scale and ambition of the Soviet program, but intelligence assets provided the crucial context of the systemic rot within: defections, compromised agents within Soviet procurement networks, and sophisticated electronic surveillance from bases like those in Iran and Turkey painted a picture of an environment defined by panic, corruption, and a fundamental lack of quality control. The Soviet space program, while brilliant in concept and staffed with genius engineers, was plagued by bureaucratic inertia and a deeply compromised supply chain, especially concerning the exotic materials needed for deep space hardware. This intelligence formed the basis for the second, far more aggressive phase, strategic technological denial, coordinated through channels often leveraging the COCOM framework, the Coordinating Committee for Multilateral Export Controls. While COCOM officially restricted the flow of high-technology goods to the Eastern Bloc, the U.S. intelligence apparatus transformed it into a weaponized denial mechanism, going far beyond simple embargo. The UNON's Achilles heel was its propulsion system. Korolev was forced, due to the political refusal of Glushko to design high-pressure, storable propellant engines, to use a cluster of 30 smaller NK-15 engines in the massive first stage, known as Block A. These engines, designed by Nikolai Kuznetsov, had never been fully test-fired as a complete cluster of 30 due to the sheer cost and the logistical impossibility of building a test stand large enough under the existing Soviet budget constraints. This meant the N-1 rockets were essentially flying prototypes, untested at full scale. The American strategy was not to target the engineers directly, but to target the components themselves. The immense pressure required in the turbopumps of the NK-15 and NK-33 engines demanded extremely high quality, high-tolerance bearings and specialized alloys capable of handling super-chilled liquid oxygen and kerosene under conditions that approach the physical limits of metallurgy. The CIA's Directorate of Science and Technology, working through front companies and third-party intermediaries, initiated a campaign of insertion, a deliberate and controlled flooding of the Eastern European and Soviet black markets with slightly but critically flawed components, raw materials, and counterfeit technology. This wasn't crude espionage with agents sneaking into facilities. It was economic warfare executed with engineering precision and scientific understanding. Consider the requirements for specialized transistors and microchips needed for the UNON's complex automatic control system, known as CORD. The Soviet Union lagged significantly in microelectronics during this period. Their designers relied heavily on reverse engineering Western components, or purchasing them through elaborate multi-layered procurement networks run by the KGB's Directorate T, the Scientific and Technical Intelligence Division. The operation involved manufacturing batches of crucial electronic components, transistors, integrated circuits, specialized sensors. These components appeared identical to their functional counterparts, but contained minute, undetectable flaws. These flaws were designed to manifest only under specific, high-stress conditions: extreme vibration during high-thrust launch, rapid temperature cycling upon engine ignition, or prolonged exposure to cryogenic environments. Under normal testing conditions, these components would pass inspection, but under the extreme conditions of spaceflight, they would fail catastrophically. One particularly successful avenue involved the strategic exploitation of the raw material pipeline for high-grade titanium and specialized nickel superalloys used in engine casings and turbopump blades. American intelligence assets seeded supply chains in neutral or complicit countries: Switzerland, Austria, various points in the Middle East, with batches of metal that contained trace impurities, silicon, sulfur, or other elements that slightly degraded the alloy's performance characteristics. These trace elements would not show up in routine, low-level Soviet materials testing, but they would critically reduce the fatigue life of a critical component, causing microfractures to propagate much faster than expected when exposed to the high frequencies and immense rotational speeds of the NK-33 turbopumps, which spun at over 30,000 revolutions per minute. The goal was cumulative failure. If just 1 out of 30 engines failed due to a pump failure or a pipe burst, the UNON's sophisticated but unforgiving engine control system, CORD, was designed to shut down the opposing engine cluster to maintain thrust symmetry. This often led to an immediate mass shutdown, a systemic chain reaction initiated by a single, microscopic flaw buried deep within a component's molecular structure. This strategic sabotage through quality degradation was complemented by an aggressive program of counterintelligence and psychological warfare aimed at exacerbating internal Soviet conflicts. James Angleton's counterintelligence staff, ever obsessed with the mole and the grand deception, ensured that existing frictions within the Soviet space program were amplified and weaponized. The feud between Korolev and Glushko was legendary and poisonous. Glushko, highly placed and immensely influential within the Soviet system, successfully denied Korolev storable propellant engines he desperately needed for the N-1 U.S. intelligence. Operations subtly fed disinformation and forged documents that intensified political distrust between the different Soviet design bureaus, known as OKBs. By heightening the paranoia about internal spies and failures, they ensured that the critical process of peer review and open collaboration, already weak in the secretive Soviet system, was completely undermined. This created a situation where necessary technical cooperation dissolved into finger-pointing and isolated problem-solving, preventing the early detection of systemic technical flaws that could have been corrected. The scale of the denial operation had to be immense to be effective, moving beyond simply denying microchips and targeting the foundational scientific infrastructure itself. The covert operation understood that the Soviet Union's ability to catch up was dependent on their capacity to run complex simulations and acquire high-fidelity testing. A key component of the American counterspace strategy involved throttling the supply of advanced computational infrastructure. In the 1960s, high-speed mainframe computers were essential for modeling the extreme fluid dynamics and complex structural loads of a 5,000-ton rocket like N-1. The U.S. and its Western allies effectively starved the Soviet design bureaus of the necessary processing power. While the Soviets developed their own BESM and Ural series computers, they consistently lagged years behind the computational capabilities of IBM and Control Data Corporation machines, available to NASA and Boeing. American intelligence worked meticulously to ensure that the small number of Western computers that did manage to enter the USSR, often disguised as agricultural or geological research equipment, were either obsolete or, in some cases, remotely compromised. This compromise wasn't necessarily a hack in the modern sense, but often involved the controlled sale of operating systems or crucial components with subtle limitations on floating-point arithmetic accuracy under extreme load, leading to simulation errors that propagated through subsequent design iterations. For the N-1, these computational deficiencies meant that the engineers could never fully model the acoustic oscillations and pogo instability, vibration modes that plague large rockets before flight. When coupled with the political pressure preventing the full 30-engine static fire test, the N-1 was doomed to fly with inherent, unverified design flaws that only advanced computer modeling could have foreseen and rectified. The psychological dimension of the sabotage program was equally sophisticated, focusing on exploiting the ingrained paranoia of the Soviet system. Angleton's staff and the CIA's Soviet East European Division knew that Soviet paranoia was a powerful inhibitor to success, and they weaponized. One documented method involved the strategic use of double agents to leak fabricated design data, known within the intelligence community as Trojan horse blueprints. These weren't entire fake rockets, but highly specific, seemingly beneficial technical improvements to auxiliary system, navigation sensor calibration revised wiring schematics for the ignition systems, suggestions for improved materials and non-critical components. These leaked designs, which would appear genuine and stolen from a Western source, contained subtle but crippling flaws. Imagine a blueprint suggesting a change in the alloy used for a non-critical electrical conduit shield within the guidance package. The suggested alloy, while seemingly superior in cost-effectiveness, might have a subtle ferromagnetic property that, when exposed to the intense magnetic fields generated by the rocket's power systems, subtly throws off the inertial measurement unit used for guidance, leading to minute but compounding trajectory errors only detectable far downrange. By the time the Soviets realized the error, the components would be fully integrated into multiple flight articles, requiring extensive and expensive rework. The goal of this information contamination was twofold. First, to introduce a real technical fault, and second, to intensify the internal hunt for traitors. When the system failed, the inevitable KGB investigation would focus on which bureau or engineer introduced the foreign design idea, further paralyzing cooperation and slowing down the process of honest technical review. Trust, already scarce, evaporated entirely. The years rolled toward the pivotal moment. By late 1968 and early 1969, the United States was on the cusp of Apollo 8, preparing to orbit the moon. The pressure on the Soviet program was intolerable. They had been first in space with Sputnik, first with a man in orbit with Yuri Gagarin, first with a spacewalk. The moon was supposed to be their crowning achievement, the ultimate proof of socialist superiority. The N1 was rushed to the first launch, designated N1L3, the third vehicle off the assembly line, occurred on February 21, 1969. The intelligence community watched, breath held, relying on signals intelligence and monitoring reports from assets near Bikaner. The rocket rose, agonizingly slowly, its 30 engines roaring in a cacophony of controlled fury. But just 68 seconds into the flight, the impossible happened. A fire erupted in the tail section. Multiple engine systems shut down in rapid succession. The massive rocket, now unbalanced and out of control, began to tumble. The cord system attempted to compensate, but it was too late. The N1 fell back to Earth, shaking the Kazakh steppe with its impact. Soviet investigations attributed the failure to a sudden surge in the turbopump of engine number 2, which led to a pipe rupture and fire, triggering the cord shutdown sequence, while the official explanation pointed to engine instability and pressure transients, issues inherent to the untested cluster design. Intelligence assessments immediately focused on the likely role of material fatigue and degradation. A microfracture in a critical feed line, or a bearing failure caused by long-term stress on slightly weakened alloys, was the textbook outcome of the targeted insertion program. The next attempt was far more catastrophic, and perhaps the closest the operation ever came to undeniable, visible success. Launch 5L, July 3, 1969, just 3 weeks before Apollo 11 was scheduled to leave Earth. The Soviets attempted their definitive launch, their last real chance to beat the Americans. The sheer power of the N1 was terrifying. It lifted off the pad, engines blazing, but barely a fraction of a second after clearing the pad, a catastrophic problem erupted in Block A. This time the failure was explosive and immediate. Within 23 seconds of liftoff, the entire first stage began to disintegrate mid-air. The N1 crashed back onto Launchpad 2, triggering a gigantic explosion that historians estimate was the largest non-nuclear man-made explosion in history at that point. The shockwave annihilated the pad structure, severely damaged the control facilities, and effectively wiped out the Soviets' ability to launch another crewed moon mission for nearly a year. The massive fireball was visible for miles, a funeral pyre for Soviet lunar ambitions. The disaster was total and undeniable. American intelligence reports, gleaned from Soviet telemetry intercepts and defector debriefings years later, detailed the cause. A foreign object, likely debris left in the plumbing during assembly, was ingested by a turbopump, causing it to fail instantly and catastrophically. This was the result of rushed, paranoid, and poorly controlled manufacturing and assembly processes. Processes that the strategic denial campaign had deliberately exacerbated by limiting access to specialized cleaning chemicals, advanced assembly tools, and high-fidelity diagnostic sensors that could have detected such contamination. The goal of the covert program was achieved not by placing foreign agents with satchels of plastic explosives near the N1, an almost impossible kinetic operation given Soviet security, but by introducing entropy and systemic weakness into the system itself. The successful sabotage was a sophisticated, invisible rot, ensuring that the Soviets' existing flaws in logistics, quality control, and bureaucratic structure were magnified to critical mass. The intelligence community had effectively weaponized Soviet internal inefficiency, turning their own system against them. The subsequent failures of the N1, launches 6L in June 1971 and 7L in November 1972, followed disturbingly similar patterns. Recurring issues in the Block A stage tied to turbopumps, vibration, and material fatigue. Each failure further demoralized the program, diverted resources, and intensified internal blame. By 1974, the N1 program was officially canceled, quietly buried deep within the Soviet bureaucracy. The Soviet Union, the nation that had first dared to touch the sky, would never reach the moon. The success of Apollo 11, the iconic image of Neil Armstrong stepping onto the lunar dust on July 20, 1969, confirmed the overt American victory. But behind the triumph lay the unacknowledged, hidden victory secured by the intelligence and scientific communities. The systematic denial campaign that ensured the Soviet rivals suffered critical, unavoidable, self-inflicted wounds. The aftermath of the N1 failures provided crucial confirmation that the decades of strategic denial had worked beyond expectations. The sheer amount of resources the Soviets had dedicated to the program, the construction of specialized factories, the training of thousands of technicians, the enormous expenditure of political capital, was now a dead weight, a monument to failure. When the N-1 was finally canceled in 1974 by Vasily Mishin, Korolev's successor after his untimely death in 1966, the political repercussions were seismic. The cancellation did more than just end the Soviet moon program. It shattered the morale of the entire Soviet space establishment. It diverted resources and talent that should have gone toward improving future generations of launch vehicles, like the Proton or the later Energia programs, into decades of agonizing postmortems and internal purges. The immense wreckage of the 4 launched N-1 rockets at Baikonur became the physical manifestation of the covert American victory. In an incredible effort to erase the visible sign of failure, the Soviets eventually dismantled the 2 remaining N-1 vehicles, designated 8L and 9L, that had never flown, and began crushing and destroying the components. The vast assembly buildings, designed to house the colossal moon rocket, were repurposed to handle the smaller Energia program. Launchpad 2, destroyed in the catastrophic July 1969 explosion, was ultimately rebuilt and repurposed to support the Soviet Buran shuttle program decades later. But the scars of the catastrophic failure remained a powerful, if unspoken, warning to future Soviet space ambitions. For the U.S. intelligence community, the success was both absolute and silent. The operations that enabled the N-1 failure remain locked away in classified vaults, largely because, admitting the depth and scale of technological warfare against a nominal peacetime rival would redefine the ethical boundaries of the Cold War. There were no medals for the analysts who pinpointed the exact purity level titanium needed for Mk-33 turbopump bearing, or for the procurement specialists who ensured that thousands of counterfeit electronic components flowed into the hands of KGB Directorate T. The success of the American effort was predicated on exploiting a fundamental asymmetry. The Soviet system was inherently brittle, centralized, and incapable of admitting mistakes openly. The American system, for all its flaws, possessed decentralized technological dynamism and a vast network of commercial and academic resources that could be covertly mobilized for intelligence purposes without ever appearing to be government operations. The legacy of America's secret moon mission Sabotage program is that of a war won through strategic attrition and intellectual superiority, not through direct military conflict. It confirms that the race to the moon was never merely a scientific competition, but a highly militarized, technologically contested battlefield where success hinged on the invisible. Microscopic details, a slight impurity in an alloy, a subtle flaw in a circuit board, or the amplification of bureaucratic distrust. The achievement of Apollo was the spectacle, the triumph broadcast to the world. The failure of the N-1, orchestrated through the calculated deployment of technological denial and supply chain corruption, was the decisive, invisible strategic victory that guaranteed the supremacy of the West in the cosmos for decades to come. The silent beep of Sputnik had led to a decade of paranoia and determination. The deafening explosions of the N-1 launches marked the end of that feat, confirmed not by the skill of American hands alone, but by the engineered collapse of the Soviet Union's greatest space ambition. The cost of victory was secrecy, and the narrative remains buried under layers of classified reports detailing the elegant brutality of economic and technological warfare waged in the shadows of the space race.